Assalamu alaikum my dear students, how are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 10 students. My dear students, our today's topic Chapter 11, Reading Turn Part 1, our today's lecture number 9 and SW number 8. My dear students, let's start our class. This is Chapter 11, Current Electricity. Nowadays we cannot spend a single moment properly without electricity, and to operate machines and other instruments around us we need electricity. So in our previous chapter we have discussed about static electricity, and when charge flows through a conductor we call it current electricity or electricity. And in this chapter we will discuss about how can we measure electricity in a circuit and potential difference. Now electric current. What is electric current? We have discussed in the previous chapter that if two bodies have a potential difference, then charge flows from the body of higher potential to the body to the lower potential. The flow of charges continues until the potential becomes equal. This flow of charge of the flow of current or electricity. Okay, so this is current electricity when which is we generally call electricity. My dear students, now come to next topic, electromotive force and potential difference. Potential difference is produced by a chemical reaction inside the battery cell. If the flow of charge starts, chemical substances start decreasing. When chemical substances are finished, battery cells cannot create a flow of electricity. The ordinary battery cells that we see regularly, we have a potential difference of 1.5 volt. The ordinary battery cells that we can see regularly have a potential difference of 1.5 volt. So for the supply of electricity that you have in your school or residence, there are 2 points of use for using it. One of them is at higher potential and another one is at lower potential. This difference in potential is maintained by a generator which develops this continuously. A battery cell or a generator has to send charges continuously from low potential to high potential for continuous flow of electricity, and for that it needs energy. So if W amount of work is done to bring Q amount of charge from low potential to high potential in a battery, then the electromotive force or EMF of the battery is EMF equals to W divided by Q. So my dear students, we have learned that what is electromotive force or EMF. If W amount of work done to bring to Q amount of charge from low potential to the high potential, then this is called electromotive force or EMF. EMF equals to W divided by Q. A battery cell or a generator which supplies electric energy has an electromotive force or EMF. When a battery cell or a generator is connected to a circuit, this electromotive force brings the charge through the whole circuit, and the amount of potential a battery produces its electromotive force or EMF, and in English it is called force, but in Bengali it is called energy. My dear students, now go to next page. Conductor, insulator and semiconductor. What is conductor? If we have understood the structure of matter properly, then we have understood one thing clearly. In solids, the atom and molecules strongly hold their own positions. If temperature is increased, the atoms or molecules start vibrating, staying at their own position and don't move away from their positions. So when you learned metallic bonds in your chemistry book, you have seen some electrons of metals atom are in a free state which can move from one place to another. For this reason, those are called conductors. Gold, silver, copper, aluminum, etc. are good conductors. Charge can be transferred through conductors, but we have to remember that this transfer of charge is done by electrons. Flow of electricity is done by electron, negatively charged electron. Okay, my dear students, so we have learned here what is conductor. Okay, so now come to insulator. The substance which has no free electron for conducting electricity is called an insulator. And plastic, rubber, wood, glass are examples of insulator. Mainly non-metals are insulator. Now semiconductor. There are some substances whose conductivity lies between insulators and conductors at normal temperature, but their conductivity increases with the rise of temperature. So these types of substances are called semiconductors. Example, silicon or germanium are semiconductor. Semiconductors are elaborately discussed in the last chapter of this book. So my dear students, from this topic we have learned what is conductor, what is insulator and what is semiconductor. Conductor means the substance which has free electron for conducting electricity, and this is called conductor. For example, gold, copper, silver, aluminum, etc. are good conductors. Insulator, the substance which has no free electron for conducting electricity is called insulator. For example, plastic, rubber, wood, glass, etc. are the examples of insulator. And semiconductor, the substances whose conductivity lies between insulator and conductors at normal temperature, but their conductivity increases with the rise of temperature. These types of substances are called semiconductor. And silicon, germanium are the examples of semiconductor. My dear students, now come to next topic, direction of electric flow. We know the flow of charge is electric current. We know the flow of charge is electric current, and so far we have tried to understand it normally. Let us specify it a little bit now. Electric current means the rate of change of flow of charge with respect to time. I repeat, electric current means the rate of change of flow of charge with respect to time, that is called electric flow. Electric current, if Q charge flows in time t, the electric current is I equals to Q divided by T. My dear students, electric currents indicated by E, Q is charge and T is time. So we can say if Q charge flows in time t, the electric current I will be Q divided by T. Now if the unit of charge is the coulomb C and of time t is t second, then the unit of electric current will be ampere. Okay, the unit of charge is coulomb and the unit of time is second, so it will be coulomb per second or ampere. My dear students, interesting thing is to find the unit of charge. We said if 1 ampere electric current flows for 1 second, then the amount of charge that flows is called 1 coulomb. Okay, so here we have learned what is electric current and what is called 1 coulomb. Electric current is the rate of flow of charge. If 1 ampere current flows from A to B, it means the 1 coulomb positive charge has been moved from A to B. My dear students, now come to next topic, relationship between potential difference and electricity. Relationship between potential difference and electricity. My dear students, now we will discuss actual flow of current in a real circuit. We have said before that if there is a potential difference between 2 points and if we cannot these 2 points, if we connect these 2 points with a conducting wire, then electric current will start flowing between these points. Though we haven't discussed the amount of electric current. My dear students, now we will discuss about this topic. Now we will discuss what is Ohm's law. To see the relationship between potential difference and electric current, we can do an experiment. The equipment used for measuring voltage is called voltmeter. My dear students, here is a knowledge based question. What is voltmeter and what is ammeter? The equipment used for measuring voltage is called voltmeter, and the equipment used for measuring electric current is known as ammeter. Now the Ohm's law will be the current passing through a wire at a certain temperature is proportional to the potential difference between its two ends. My dear students, I repeat, Ohm's law is the statement of Ohm's law is the current passing through a wire at a certain temperature is proportional to the potential difference between its two ends. And not only this, we can also change the direction of potential difference by reversing the cells. So, if we apply different positives and negative potential difference between two sides of a wire, some other conductor, and try to measure the current flows, we will see that number 1, the higher the potential difference and the higher the current flow. And if the potential difference is negative, the electric current also changes its direction. Okay, and therefore I proportional B. My dear students, see here, according to Ohm's law, the current passing through a wire at a certain temperature is proportional to the potential difference between two ends. Here see, suppose this one is a wire, this one is A point and this point is B. The potential difference between these 2 points is VA and this one is VB. Okay, so the current flowing is I. So according to Ohm's law, the current will be the current, that means I is proportional to B. That means current is proportional to the potential difference. Here I is current, electric current, and V is potential difference. So from this is Ohm's law, and from this equation we can write I equals to V divided by R. Here I is electric current, V is potential difference, and R is resistance. Okay, my dear students, this is Ohm's law, and we have to you have to learn properly this Ohm's law. The current passing through a wire at a certain temperature is proportional to the potential difference between its two ends. That is I proportional V, or I equals to V divided by R. My dear students, now your today's SW number is 8, and this knowledge based question you have to write. Number 1, what is EMF or electromotive force? Number 2, what is conductor, insulator and semiconductor? Question number 3, what is 1 coulomb? And question number 4, write Ohm's law. My dear students, I hope all of you have understood our today's topic. Learn properly this question answer. Submit SW regularly. See you again in the next class. Allah Hafiz.